Hi. Uh, Before I start the video today, I want to make a quick announcement, and that's that I'm going to be posting a lot more HackerRank and lead code videos soon. So if you like how I teach or go over some of these problems, please subscribe. Okay, so today we're going to do the high security and strings problem on HackerRank. And this is a part of their Hack the Interview um, question series. So I got this one from a previous year to study. And we're going to go over first what this problem is asking, and then we're going to tackle it. And based on some of the solutions that I've seen, a lot of the solutions were tackling this problem in big O of n squared time, but we're going to be able to do it in just big O of n. Okay, so what does the problem ask? In this problem, we're going to be given two things, a string and an integer. Let's say we're giving a string such as hello Mr. Z. So there's some constraints to this string that we're going to be given. The first constraint is that the string will always be lowercase, and that there will not be any spaces in this string. The second value that we're going to be given is an integer, and we're going to talk more about what this integer means. So let's say the integer that we're given is 2. Given these two inputs, what we're supposed to do is we're supposed to find the sum of all of these values where the starting position would be the second value. So right here, if you could see, as you can see, I've written down the entire alphabet, and if you assign them their own values, right? So A would have the value of 0, B would have the value of 1, C would have the value of 2, so on and so forth, right? So what this first integer is telling us is that A will now have the value of 2. So A has the value of 2. Well, let's have A have the value 2. This means that all subsequent letters will have an increment of this 2. So A is now 2 instead of 0. B is now 3 because 1 plus 2 is 3. C is now 4. Right. So as you can see, I filled out the rest of these values that they will now be. So as you can see, G used to be 6. Sorry for how this might look, but that's innate. H used to be 7 and it's now 9. I used to be 8 and it's now 10. As you can see, all of these values have been shifted basically by 2, which is what this value right here made us do. So we'll do this all the way up to we reach the value 25. So what we have to do once we reach the value 25 is we have to reset the values that we're using. So we could only use these values 0 through 25. So what that means is that once we pass x, the next value would not be 26 because we don't have a 26 here. The next value would actually reset back to 0, and then 1, and then 2, and so on and so forth. So this integer right here, what A could be, can be any value 0 to 25. And we have to figure out how we could associate each letter with its new value. So how are we going to do that? Before we move on, I want to introduce you to the ASCII table. And the ASCII table is basically letter representations of every value or every character. So we could see here A, for example, would be equal to 97. I want to show you guys what I get when I try to print out the number representation of A. And we do that by printing the character A plus 0. Once we run that, we'll get 97, which again is its ASCII representation. Now, we will create a constant variable, and we're going to call it init, and we're going to set it to 97. Now, we're doing this because we want to flatten out every value. So we'll subtract A by init. We'll subtract it. And that gives us 0. So every subsequent letter should give us one more, such as B gave us 1, C is giving us 2, and D gives us 3, and so on and so forth. We'll take the first letter, H, and its representation valuing 7, added by 2, which is A, and we'll check if it's less than 25. The reason that we're going to check if it's less than 25 is because 25, here circled in red, is the maximum value that we could use. So we have to check if it's less than our maximum value. If that is true, then our total variable would be added to itself with the new value being simply the sum of the current value plus A, in this case 7 plus 2. Current value being 7 and 2 being A, which will give us the new value 7 plus 2, which is 9. Now we'll move on to the second letter, which is E. And E is 4. Again, we'll add it by A, which is 2. And we'll check if that is less than 25. In this case, it is. So we'll add that to the total. 4 plus 2. Now we're going to move on to the last letter, Z, and we're going to write the current value of C being 25, again added by A, which is 2, and we'll see if that's less than 25. So 25 plus 2 is 27, which is in fact not less than 25. So we'll create an else statement for that situation. The way that we're going to convert 25 into 1, we'll subtract 25 current value minus our max capacity, which is 25. We will then subtract our maximum capacity by A, which in this case it's 2. Finally, we will just have to add 1. And this is what we're going to implement. Alright, now to implement the code. As said before, we're going to iterate through the password being the first string that we're given. It is equal to 0 is less than length plus. Alright, so we're going to check if the value minus init, again, init is the ASCII value of A being 97. We are going to check if the new value plus weight A, which would give us the new value, is less than or equal to 20. If this holds to be true, then total, which we have not declared yet, int total, will simply be password character at minus init plus weight. The total would be added to the new value, and the new value is just the current value here plus whatever amount we have to add it by. Otherwise, if that is not the case, then total will have to be current value of the character minus maximum we could hold being 25 minus the weight that we are given plus 1. Finally, we would just have to return the value of total. So one more time, we have init being the ASCII value of A. We're going to go through all the characters in our password, and if that new value is less than 25, then we just add that new value. Otherwise, that new value would have to be subtracted by 25 being the max capacity minus the weight plus 1. We then return total, and we'll now run the program to see what happens. There we go. All test cases accepted.